Welcome on behalf of the entire American Red Cross and our national headquarters International Humanitarian Law Program. I want to welcome you to this fantastic webinar today. My name is Thomas Harper. I serve as Senior Counsel in International Humanitarian Law for the American Red Cross. It's my absolute pleasure to bring together this brain trust. I don't know of a better way to describe the group that we have on the call here, because I think the collective knowledge and brain power of these individuals you're about to hear from could fuel a rocket to Mars and beyond. So without further ado, I'm going to hand it over to my colleague, Rebecca Socha from our American Red Cross Illinois region to introduce our panelists and kick us off. Rebecca, it's all yours.
Thank you, Thomas, and welcome everyone. Thank you for joining us this Wednesday to learn about outer space and resources and armed conflict and the future of space law. My name is Rebecca Socha. I'm the Regional Specialist for Service to the Armed Forces and International Services in the Illinois region of the American Red Cross. I'm truly honored and excited to introduce to you our panel. So we'll go ahead and just start introductions right now. Joe, if you want to introduce yourself.
Sure, thanks, Rebecca. Hi, everyone. My name's Joe Zader. I am the director of the brand new Snow King Observatory and Planetarium, top of the mountain in beautiful Jackson Hole, Wyoming. We just opened the observatory in June, so still pretty fresh. And that's pretty much what my 2024 has been, is getting this place up and running. Prior to this, I was at the University of Colorado in Boulder, where I was splitting my time between science education for the public at Fisk Planetarium there and the Laboratory for Atmospheric and Space Physics, where I was on a Mars mission called MAVEN, specifically the Imaging Ultraviolet Spectrograph team. And I'm excited to be here to talk about space. I always love talking about anything about space, and I think this is a very appropriate kind of topic and appropriate time to be discussing these sorts of things. So thank you for having me.
We're happy to have you, Joe. All right, Mallory, do you want to introduce yourself?
Hi, I'm Mallory Smith. I'm the vehicle manager for the Habitation and Logistics Outpost. It is a lunar space station that Northrop Grumman is building for NASA as part of the Artemis program. It is going to be part of the broader Gateway program, pretty similar to the International Space Station, is orbiting around orbiting around Earth. Halo and Gateway will be orbiting around the moon. So it's a really amazing program to be part of. We are gearing up for integration and testing of the whole vehicle in Phoenix, Arizona. I'm based out of the Chicago area. I actually work with Rebecca as a Red Cross volunteer on the Restoring Family Links program. So very excited to be here and kind of meld both worlds between work and building a lunar space station and helping out the Red Cross.
Thank you, Mallory. We're happy to have you here. And Michelle, can you introduce yourself?
Hey, everyone. I'm the boring one. I'm the lawyer here, so don't boo and hiss. I think the space law in particular is really exciting because there's not that much of it, and I'm really excited to talk about these wonderful projects and how space law can help us become a truly multiplanetary species. I'm the executive director of the Center for Air and Space Law down here in Oxford, Mississippi. I've been practiced business law for about 25 years before I immersed wholly in space law. And I'm just so excited by all of the activities that are going on in space right now, especially related to space resource utilization, because I think that is a real opportunity for humanity. And so I'm just delighted to be here. Thank you.
We're happy to have you here, Michelle. All right, let's dive in. This question is geared more for Joe and Mallory, but what can you tell us about what's happening in outer space? What are some projects and different things going on already that you may or may not be working on together?
Sure. I guess I think I'll jump in. And I mean, there's it's kind of amazing how much is going on with space right now in terms of rocket launches, missions going on. Of course, there's a lot of very big flagship ones that get a lot of the press, as they should, like the Artemis missions going, back to the moon to settle there for good. But another big one that's actually supposed to launch tomorrow, but due to the weather situation, the hurricane in Florida, it will not be launching. But the Europa Clipper mission that'll be launching to the Jovian system around Jupiter, I should say. The second Galilean moon of Jupiter called Europa. So, there's rocket launches happening every day. There's missions going back, many years that kind of looked at the possibility of mining and asteroids and what kind of composition they have and things like that. I think even going back to, I think it was 1991, was the first time that humans did a flyby of an asteroid to try to get some information from it. That's progressed many times in the last few years to even as far as bringing back samples from asteroids. Both the JAXA, Japanese Space Agency, and NASA have done sample return missions that have been successful. And then looking forward to, there's already missions that have launched in the last year or two that'll take about 4 or 5 years to get to their destinations. Most notably the Psyche mission that'll be going to a very metal-rich asteroid. So this is something we could talk about for hours about how much is going on in space in the last 10 years and the next 10 years. We can. I don't want to take all the time because I know what Mallory to chime in here too. But there's a lot to talk about that we can get into.
Yeah. So from my perspective, I'm mostly focused on the lunar side. So like I said, we're building the first piece of Gateway, which is a lunar space station. You see it behind me. It's called Halo. We are partnered up with Maxar, who is providing the propulsion element. It's called PPE, the power and propulsion element. It's getting launched on a SpaceX Falcon Heavy no earlier than 2027. And the goal is to build it up like the International Space Station. We have a lot of partnerships already with different modules that will eventually birth to Gateway. On the lunar surface, we are making a lunar terrain vehicle. So there's different partnerships with vehicle manufacturers and putting what looks kind of like a go-kart on the moon. Lunar habitation is another big push right now. They're building a lunar train track and investigating resources in the lunar regolith. The biggest, I think, push for exploration right now is the lunar South Pole, just because of the ice that is likely there, and exploring that. From the lunar perspective alone, let alone Mars, there's definitely a lot of exploration going on right now as part of the Artemis mission, let alone all the launch vehicles needed to support those ventures. Whether it's SpaceX or Blue Origin, it's like probably the best time to get into the space realm. Not to mention there's a bunch of smaller startups for launch vehicles like Relativity Space that they're trying to 3D print their own rocket. So it's definitely a new boon for the space industry.
And I'm glad you brought that up, Mallory. Can you guys tell us who or what is currently operating in space? Are there different countries operating? Are they working in cooperation and collaboration? What type of private sector organizations are currently working in outer space as well?
I would just jump in and talk because I think Mallory had a great point talking about Gateway, right? And one of the most successful collaborations we've had in space is the International Space Station, and Gateway and the Artemis Accords that are sort of they're a non-binding, they're not a treaty, they're non-binding principles, but that's how the United States is hoping to collaborate and bring more countries in. 44 countries have now signed the Artemis Accords, with the Dominican Republic signing yesterday. Woohoo! And so it's a really exciting time to think about collaboration. The United States looked at the Apollo mission and looked at the Artemis mission and realized we can't do it alone, and we don't want to do it alone. And so it's a really exciting time. The problem is, and as I'm sure most everybody on this call knows, is Russia and China have not signed the Artemis Accords. And they have actually started their own lunar program, the International Lunar Research Station. And so we have two competitive programs. It's a race. And you know what? Races are good. The competition is good. But the stakes are very, very high this time. And I know I want to hear more about Northrop Grumman and some of the other commercial entities that are involved both in Artemis and also on their own.
Yeah, so from the international collaboration, just on Halo, so just, this one small segment of what will make up Gateway, we have JAXA, the Japanese Space Agency, providing our batteries, the lunar communication system that's provided by the European Space Agency, the Canadian Space Agency, they're providing robotics. The UAE recently signed on to provide the airlock. There is a variety of payloads from other countries. And this is just going on Gateway. So like Michelle said, with these 43 countries signed onto the Artemis Accords, there's definitely a lot of interest, even from smaller countries like the Dominican Republic, to contribute in some way to the future of space exploration.
Yeah, I guess to jump in from my perspective too, I mean, in taking a step back, even larger view, science in general, nowadays is a very large collaborative effort. It's something that takes teams of not just dozens but hundreds of scientists and engineers working towards the goal. I mean, there's still some people who have that misnomer in their mind of the scientist being the lone guy in the lab, by himself making discoveries, the eureka kind of thing. But that's just not the reality. And just speaking from my time at at CU Boulder at the Laboratory for Atmospheric and Space Physics, when we would have our team meetings and things like that, we'd regularly have people remoting in from 10 different countries that all have parts of or things in motion under the larger part of that mission. And the functional teams might be several dozen people, but then when you get together with the larger team for a mission, it's hundreds of people from possibly dozens of countries, and had many colleagues who would often be flying over to the UAE and things like that for collaboration. Generally, it's maybe that little bit of a push and pull between competition and collaboration. And I think there's always a little bit of that. And it really is helpful, I think, to have that push and pull for both of them on that kind of larger scale level.
So it definitely sounds like we have a lot of different countries, different governments involved working together or in competition to further fuel scientific research. Mallory, you had mentioned SpaceX and Blue Origin. What other type of private sector companies might be collaborating on these different projects like Halo or Artemis?
Yeah, so like I said before, there's a lot of new players. There's smaller companies that are interested in space exploration and getting funding through like venture capitalists. I know there's Lunar Outpost, who is involved in. They're actually based in Colorado. They're involved in the Lunar Terrain Vehicle program. They do a lot of navigation on the moon. Kind of like Google Maps of the moon, using the Lunar Reconnaissance Orbiter for a lot of information for map generation. I talked about Relativity. They're a company based in California where they're 3D printing rockets. There's just so many smaller companies nowadays. There's Astrobotic. There's a bunch of different robotics companies. Like, you don't have to make a spacecraft in order to be involved in this community. Like, there are so many smaller niche, especially within robotics specifically, that we're reliant on to make missions successful.
So Michelle, we have a lot of different people operating in space through governments and private sector. What can you tell us about laws that govern outer space, and especially international humanitarian law, in the event that a conflict were to arise in outer space?
So first off, two things to remember about space law is there's not a lot of it, and international law applies in space. That's one of the fundamental precepts. And so when we talk about, everyone considers, oh, it's a wild, wild west, it's a new frontier. You can fit all of space law on one slide. This is one of my favorite slides. And for you lawyers out there who haven't taken space law, Imagine going through your 1L year and spending all that time looking at cases and books and codes and regulations. And then you get to my class and you're like, yep, this is it, all on this one slide, international space law. The fundamental precept of space law is freedom of exploration and use. And so that means you can go into space and do whatever you want. Freedom of exploration use, except there are a few prohibitions. You cannot place nuclear weapons or weapons of mass destruction anywhere in space. International law applies, and so that means IHL will apply. And also, you can't claim territory in outer space, or a sovereign can't claim territory by means of sovereignty. And so we have it's really fascinating for me to hear about all these wonderful plans for the moon. I mean, a train on the moon, think about it. Well, do we even have the right to claim putting train tracks on the moon is claiming territory by occupation. And that's essentially a violation of law. And so we're looking at this, and it's not just Northrop Grumman or the United States, because China is planning, and China and Russia are planning an entire research station. And it's interesting because we have built right into the law this uncertainty, because Article 2 says you can't claim territory, but then Article 12 says, hey, if you happen to have an installation, then everybody else has to give you a little bit of birth, right? And you have to have due regard for people. And so we're really looking at this area of law that that we really don't know the answers yet. And we're really sort of taking little baby steps and making it up. And I mean that, making it up as we go along. We have a framework to interpret, but there's a lot of different ways to interpret that.
Yeah, Michelle, and I think even contradictions, right? Like, so the Artemis Accords, I know there was a lot of debate on if some of that violated international law in regards to the US really owning the verbiage for those accords. Can you talk to anything about that? Because that's kind of something that I'm interested too, is like, when you have all these space laws and treaties, when there's contradictions of them, like who trumps who?
So that is exactly right, Mallory. There are so many gaps in the outer space treaty. Actually, my other slide that I usually have is it says mind the gap and the inconsistencies, right? And so the Artemis Accords are a real effort to fill in those gaps. And again, remember, the Artemis Accords are a multilateral pact. They're a political commitment. They're not binding and enforceable on anybody. They're not the US imposing their views on anybody. This is how the United States is going to interpret the Outer Space Treaty. In many ways, it's incredibly transparent and saying, look, this is what we think. And it actually started in 2015 when President Obama signed the Asteroid Act, right? When the United States came out and said, we are going to interpret Article 2 to say that we're not going to claim territory. But if we extract a resource, if we take it out of that territory, then you can own it and you can sell it and you can buy it, you can eat it, you can do whatever you want with it. And so this is what a lot of nations objected to, is that interpretation of Article 2. Now, what we've seen the United States has done, though, is it has continued to push. So sort of, pushing at the edges and saying, we've got to talk about this because we're all going back. And it's not just the United States and Artemis, it's China, Russia, and India has its own independent plans, South Korea. So how do we push it? And the United States said, we appreciate the UN process, but it takes a long time. And so in the meantime, we're just going to put out there how we're going to interpret. And so we have this concept that if you mine it, you own it. And then they introduced safety zones. What do they mean? What are they going to look like? And oh my goodness, that is imperialistic. And what have you done, United States? And so that's where we are now. But the United States, that little bratty kid in the playground nudging everybody, has sufficiently nudged the United Nations that now there's an actual working group on space resource utilization to look precisely at whether the Artemis Accords have it right or wrong. How are we going to interpret it as an international community? And made it even more exciting, in June, the UN supported the action team for lunar activity coordination. And so this is a purely technical team that's just going to inform and give everybody the opportunity to be transparent. And so these are like huge tidal waves in international space law, even though they might not seem like much to the observers.
No, I think
Go ahead,
good.
Joe.
Just to, and hopefully my voice is coming through a little better now. I switched mics. I think those are one interesting thing about the slide you had up that I guess kind of was a stark contrast to me is it looked like, you know, there was a lot that happened around the Apollo era in terms of space law, and then a very much of a lull for quite a while until, you know, the last maybe 10 years or so. And I think even looking at that on the surface kind of tells you that we are back into a race, as you were saying before. And I think the point about nudging the United Nations to get to working groups and things like that, I think that's you know, a necessary sort of thing to get some framework and understand it, because it still does feel a lot like the Wild West in many ways. I mean, we have, you mentioned many different countries that are, you know, going to the moon. There's been a lot of those landers that even by private companies like in Intuitive Machines, I think it's called, in Texas, and that landed recently with the CLIPS program from NASA, the Commercial Lunar Payload. You know, there's other companies that are basically already staking their claim in terms of this is an asteroid we want to mine and send some you know, send some small refineries as a proof of concept sort of thing. So all of that is charging ahead, and I think we're still, you know, there's so many challenges that until it's a viable sort of business. But I think it's at the point where, you know, it's inevitable that it's going to happen, that it's going to be different companies and countries charging forward to try to stake those kind of claims. So the more you have that framework, I think the better. And it's good that we've kind of been that, you know, person on the playground prodding a little bit, I think.
Absolutely.
And Michelle, I want to follow up with one question for you. So we definitely have a lot of cooperation and a lot of competition in space, and we don't have a whole lot of legal guidance on outer space law other than other international laws that apply. But what can you tell us about what would happen if potential conflicts were to arise, and what laws would be utilized to you know, follow up with whatever type of conflict happened?
The space law is a subset of public international law. And I want to point out, if you remember that slide, there were sort of 5 treaties on the left-hand side that were a little bit larger. Everything else on that slide is voluntary. So we're really talking just about 5 treaties that are binding. And thank you, Thomas. And everything else is just a resolution. Like, we aspire to do these things together. There's nothing binding there. It's all voluntary. Now, none of these, the Outer Space Treaty does not have any enforcement provisions. The Liability Convention says, well, if you do damage to somebody else in space, or if your space object does damage to somebody on Earth, then you owe them for it, okay? There's nothing that says if you violate the peace that we're going to do something. It's all about damages, because, you know, one of the fundamental precepts of the Outer Space Treaty is the concept that we are entering into this treaty in order to maintain the peace in space. And this is a really important distinction that lawyers need to make, because people automatically assume that, you know, all of space is to be used exclusively for peaceful purposes. And that's not what the law says. The law says we aspire to use space exclusively for peaceful purposes, and we are obliged to use celestial bodies exclusively for peaceful purposes. But the rest of space is fair game. So what happens? Again, international law will apply to a conflict in space. You will go to the International Court of Justice. We have a provision called due regard. I call it the lawyer's cha-ching provision, because it's not a bright line rule. It's a totality of the circumstances rule. We're going to look at everything that's happening and decide who's really at fault here. And us lawyers, you know, we can make that argument, you know, and appeal it and appeal it and appeal it. And all of a sudden we're spending a lot of money on lawyers and not enough on exploration. So no, just like public international law, if something goes wrong, if there's a conflict, what happened when Russia invaded Ukraine? We all went, hey, that was really bad. You know, we're going to sanction you. And that's exactly the courses we'll have to take with respect to space activities.
So of the 5 binding treaties, have they ever been violated before? Has anyone ever been held responsible? You know, if their space item fell to Earth and caused damage, have we had any instances of that happening?
Absolutely. A Soviet era satellite broke up over northern Canada, over the northern provinces in Canada. It was unfortunately powered by a nuclear reactor. And so all these pieces of little tiny pieces of radiated metal and so forth fell all across the Northwest Territories. And so what happened was that Canada cleaned it up and sent a bill to Russia, which is what you do under the Liability Convention. And there was some negotiation because it doesn't go, you get to have an arbitral panel and you make decisions and you negotiate and you do it through diplomatic channels. And then they ultimately settled, I think, for 2 million Canadian dollars when the cleanup obviously was much more than that. We've actually had a very exciting case for lawyers. Very recently, a piece of station fell on a house in Florida, right? And what's fascinating to us is, okay, if that piece of station had fallen on a house in Mexico, international law applies. You don't have to show any negligence. The United States caused damage, and the United States must pay. But because it fell in the United States, the international law does not apply. And so that homeowner has to claim damages through the US government Federal Tort Claims Act, which requires you to show negligence. And so we see, even without thinking about it, we've created these sort of two different systems under international law and domestic law.
Yeah, something that's interesting about the ISS and, that crash into the home in Florida was that the ISS deorbit program is now kind of gearing up too. So I know like folks had been concerned, well, are we going to be concerned about debris breaking up over my house? And so that's like that's a large program right now that corporations are trying to bid is how are we actually going to deorbit this massive international space station? And what does the collaboration with Russia look like on that? So it's an interesting problem that we're going to have to solve in the next 10 years, and something that NASA is actively trying to fund.
Yeah, an interesting thing about that too is just I think that also can speak to a larger issue too of if there are there does end up being a number of countries and companies that are, sending spacecraft out there to do some kind of mining, whether it's, moon, asteroid belts, or anything like that. That also begs the question of the return trip and how they go about that. And if there's already been other cases of, rogue satellites or decommissioned satellites that would be breaking up, and and generally they're designed to break up in the atmosphere and then have the debris go into the oceans. Vast majority of the surface of the Earth, of course, is oceans, so it's likely to happen that way. But if we are having a larger influx of spacecraft that would be coming into low Earth orbit and things like that, then that's a risk then too. That whether it's a company that is not necessarily under the guise of an ally country or something like that, or if it's just a number of countries that want to continue to bolster their space program. I mean, like the Indian space program, ISRO, has had a lot of success recently. I know Israel's looking to have a lander on the moon the next year or so. There's more and more players, and that could get more and more crowded. And the idea of having to deorbit things or have them drop off payload of refined materials or something is something that, it needs to be thought through a little bit. Granted, we're probably a good decade away from it being any kind of real issue with lots of different players, but that's a kind of a corollary to that sort of ISS issue that Mallory's talking about too.
If I can jump in, Joe, I think you raised a really good point. When we think about, and then we're supposed to be talking about resource utilization, and I want to just raise, 2 points. What is a resource? One of the resources in space is the stuff that's already up there. I run an organization called For All Moonkind, and we want to protect human heritage that's found in space. And I was speaking to Harrison Schmitt, and I was like, don't you agree we ought to protect Apollo 17? And he's like, no, we ought to recycle it. It costs a lot of money to get that stuff up there. It costs a lot of money. We ought to be using this stuff again. And I think when we talk about mining lunar resources, more so than asteroid resources, there is going to be, we left a lot of junk up there with Apollo. There's a lot of spacecraft that we just sort of crashed into the moon, humanity, like, oh, do you think we can reach it? Yay, we reached it. there's a lot of junk up there already, and we don't have any rules in place with respect to what you can send up there, what you do with it when it stops working. We're beyond the point where everything that goes to the moon should be considered heritage and protected. And so one of the things that I think we're not thinking about enough is, okay, we keep testing these things. I mean, we had Astrobotic and iSpace both crash. Astrobotic didn't make it. Sorry, iSpace and Space IL crash landed on the moon. The Russians crash landed on the moon just before Israel landed on the lunar South Pole. And now we're really just sort of in this race to just see who can crash something in first. And I think that's a problem.
And I'm glad that we're talking about the moon right now. And I think for a lot of us, it's more, we see the moon every day, obviously, depending on what cycle it's in, but we see the moon, but we don't see other planets. We don't see asteroids. We don't see different things further out in the universe. But can you just talk about specifically with the moon, what type of maybe contradictory things are going on with protecting resources on there, as well as utilizing resources and, maybe mining different things and just other aspects of the moon. I know, Mallory, you're working closely on the project for Apollo, but can you shed more light about what's going on specifically with the moon?
Yeah. So the reason why there's such a focus on the moon, and something that, my NASA customer always pushes is moon to Mars. The moon is really a proving ground, a jumping off point to get to Mars. It's a lot closer. We don't have the Earth's atmosphere where we could potentially launch other spacecraft from the moon to get to Mars. For lunar resources, I would say probably the number one would be, it's called helium-3, which could potentially be used for fusion reactors here on Earth. In terms of like pure value of like heavy metals, there's not a whole lot on the moon. I think like the biggest reasoning why we're wanting to go back there is it's strategic. Helium-3, I think, would be great to use maybe on the moon, but bringing it back might not be, a great return on investment. I think our biggest push right now is getting to Mars and then using the moon, like I said, as a proving ground for that next leap.
Yeah, and just to add to that too, I often get when we do public events and things like that at the observatory here. That's a question I often get is why is it such a big deal to go to the moon again? We've already we've been there, and I think to Mallory's point, there's a couple of different factors. That one, the proving ground, like Mallory mentioned, it's just one thing we got to keep in mind though is even as routine as it seems to be launching rockets constantly and you hear so much about space travel and exploration now, it's still a very difficult endeavor. There's still a lot that goes into it. And the systems, the computer systems, everything that we have nowadays is very different than the Apollo era. So we need to understand how to do these things again with modern technology and how to do them better. Artemis 2, for instance, is going to do essentially exactly what Apollo 8 did and orbit around the moon and not actually land there. It won't be till Artemis 3 that they actually will land. And it's testing those systems, understanding how they all work to get us as a jumping off point to Mars. In terms of the resources on the moon itself, really the most besides the helium-3 that Mallory's talking about, in my mind too, it's really the water ice that is the big thing. That's one of the reasons why we want to look at the South Pole region of the Aitken Basin. It's called. There's a lot of water ice that's really been there since the formation of the moon in pristine condition and craters that have been shielded from sunlight for 4 billion years. And harvesting that is important for, not just the reasons we would normally want to have water, but it's also then you can use it as rocket fuel, and you break that apart into the oxygen, the hydrogen, and that's something that can be, a propellant for actually getting to Mars or other endeavors on or around the moon as well. So even if it's not necessarily mining materials that you'd bring back for to use on Earth, there's still a lot of reasons to be going to the moon before you can actually go to Mars or even go to asteroids, which are the kind of the leftover building blocks of the solar system in many ways. It has a lot of the rare earth minerals and elements and things like that that are difficult to find on Earth. So a lot of really important reasons why the moon is the next big focus. And if nothing else, keep in mind how big space is. It's the moon is 380,000 kilometers away from Earth, a 250,000 miles. Which is a fair distance, but we can travel that in a couple of days. I think it was like 4 days that Apollo was doing it in. Whereas as Mars and the asteroid belt, that's a much longer trip, and it's not like it's a neighborhood sort of drop by.
And I would add, I think I agree. Right now we're looking at water as the most valuable resource on the moon, other than our heritage, right? But and just as you said, that our understanding of the moon right now, the moon is big. A lot of people have said, oh, it's the 8th continent, it's full of resources, but there's not going to be conflict. There's plenty of room for everybody. But everyone's focused on that lunar South Pole because we think that's probably the easiest place to extract that water that the Chinese need and the Americans need, right? And so if you put the 2 maps on top of each other about where Artemis and where the International Lunar Research Station are thinking of landing, they're right on top of each other. And so that's an incredible conflict, and that we truly need to race to beat so that we don't have actual conflict.
And I do want to be mindful of time. I do see we have about 10 questions in our Q&A. So I just have a few follow-up questions, and then we'll move into our Q&A. So what does the future of outer space look like with collaboration and conflict? And personally, each of you, where do you think the future with space law and space exploration lies?
I'll go
I think we're
first.
going to.
Go
Oh, go ahead,
first.
Michelle. Okay. No, I was going to say the private sector, I think, is going to be the biggest push. I mean, we're going to still see, NASA or, other country sponsored space missions. But, there's a big push to have commercial space stations that, tourists can visit. So there's not going to be as much of a dependency on NASA for funding. We're going to have, firms like SpaceX and Blue Origin, who are pretty much self-funded for a lot of what they've done, especially in the beginning of their company, pursuing missions on their own. Obviously, they still need to abide by international law, but I think that's going to be the big push: is less reliance on government funding, and more commercial exploration.
So I couldn't agree more. And I don't know if that's, and I'm happy to hear Mallory say that, because I'm not in the industry. I'm just the lawyer. And so I don't know. I never know if it's wishful thinking or if it's actually going to happen. So yeah, I think we're going to see a growth of commercial space. I think we're going to see a real weakening of the sovereign system. One of the things that I always talk about is sort of peace from space. We've found it very, very difficult to, establish peace on Earth. But we have this, what Frank White calls the overview effect, right? The more people who go to space and look back and see Earth as that pale blue dot, the little blue marble, whatever you want to say it, and experience what Edgar Mitchell said, right? Let's bring those damn politicians up here and show them what they're fighting about. And so I think the more people we have going to space, the more we're going to realize our humanity together. And so I think it's inevitable. I know there are a lot of, recently there have been books and articles about, oh, it's too fast, humanity doesn't deserve space yet, we should slow down. I can't answer that. I don't know if we're ready or not, we're mature enough or not, but we're not stopping and we're not slowing down. And so let's embrace it. And I think that that is the only way, and I don't mean this in the dire Stephen Hawking, we're going to die if we don't get to another planet way. I think we save our planet by going to space, by finding resources someplace else. We save humanity by expanding. The Polynesians developed the South Pacific Islands and went across the oceans because their islands got too small for them. And that's exactly where we are right now with humanity. The Earth is getting too small for us. You know, we shouldn't have to be, having a one-child policy. We should be expanding into what is essentially the biggest backyard in the universe. It is the universe.
No, but that's really well said. I think in our most basic nature, we are explorers. We're wanderers, and we want to see what's out there. And I think I'd agree with both of you that cooperation and collaboration, I think, is going to be the way forward. On many levels, and commercial space is huge. One way I think about it is the commercial aspect of space is very useful for efficiencies and economies of scale, and figuring out how to do things over and over again, logistics and things like that. I think the role of government agencies, NASA, things like that, would be to continue to push the envelope and progress things to that next level. And I think that's really the story of the next coming decades, is those incremental improvements and incremental changes. Thomas, I don't know if you got those slides I'd sent you, but I think it was the second one I had that had a list of a couple dates and some of the asteroid explorations. But essentially, going back as early as the 70s, we had this idea of exploring asteroids and exploiting them for the benefit of mankind. And over time, very slowly, we kept doing more things like a flyby, then a closer flyby that was 15 kilometers off the surface, and then a successful landing that was kind of by accident. It wasn't meant to be a lander, but it was, it kind of reached the end of its life and it landed. And every few years, we have a new step that would kind of bring things to a higher level. And I think that's kind of where we're at now. Here we go. It's this is meant to be just a quick little overview. This is not even 10% of the missions that have been out there, but it just shows how every few years we step it up to a new level. And then most recently with the OSIRIS-REx returning over 100 grams of a material from the asteroid Bennu. We've since launched, I think we already talked about Psyche a little bit, how that's going to a metal-rich asteroid. It'll take many years to get out there, but I think this slow progression is something that can continue with the government agencies and things like that can push the envelope, and then the commercial aspects of things can work together to understand how to do it better, how to do it more efficiently, how to make it actually cost effective to go after these sorts of things. So I couldn't agree more that I think it's super exciting. I think the way forward is cooperation. Hopefully we'll have more people that can experience that overview effect like Michelle was talking about. I mean, that's a very powerful sort of thing that pretty much I think every astronaut has talked about. Or even like Carl Sagan, how you would say, look down there and there are no physical, you don't see borders like drawn on a map like that. We're all one humanity kind of thing. And hopefully we can figure out the geopolitics to continue forward with that without it being another race that could lead to a Cold War or something like that.
And I think even internal politics, just among the US, I mean, recently the Starship team and SpaceX were at odds with the FAA because, there's such a push for commercialization that, the government, in the red tape that comes with it, all the regulations, which are there for, for good measure and for safety purposes. But, there's concern from these commercial entities that, they're not keeping up with the pace in which they're trying to launch these rockets. So trying to work around that aspect of it. And, we're trying to be as innovative as we can. But there's still these fail safes that are, within these laws to ensure that, nothing goes awry. So there's got to be a balance between the two.
This is just fascinating, and I'd love to listen to all of you talk more about this. This is such a fascinating topic with space law, but just being mindful of time, I do want to move over to our Q&A. So if you have any questions, go ahead and type it in the Q&A, and we will get through that. But let's get the first question.
We have a winner for best question, which is the person who asked about the movie Armageddon. So I hope we get to that, but I'll let you steer the ship, Rebecca.
I will make sure we get to that. All right. Our first question is from Bo, and he said, with all these partnerships going on in space, especially when it's both civilian and military stuff, Do these deals put civilian scientists at risk of being seen as military targets under IHL?
Yes, there is that very real concern, and we saw that with respect to the Russian statements about Starlink and the Chinese statements about Starlink. Both Russia and China have indicated that they feel like Starlink is a target of war, a legitimate target of war. And so when we think about space and how we use things, Joe was just talking about how we want to rely more on commercial space because it's faster, it's more efficient. We've seen commercial space teach us a lot about resiliency, and we're seeing more and more contracts. In fact, our government policy is every policy about space talks about the government wanting to support the commercial space industry. And just to focus back on what Mallory said at the very beginning, this is the time to be in space because our entire government is focused on, building this commercial space industry. Problem is when we talk about any satellite is potentially dual use. Any satellite can be used to destroy another satellite. Any satellite can potentially be giving very valuable information to a government about another country's national security. So there is a very real concern about how we're going to deal with that. And there are actually two, very smart academics have gotten together and produced two huge volumes about how IHL applies to space. And so it's the Millimos is one, and the other is the Woomera manual. One was put out by an effort led by McGill University, the other by a university in Australia. And so this is something that we're thinking about an awful lot.
Yeah, and I guess just to add to that too, I think that's a great point. And then just from my perspective too, and I'm sure Mallory, you probably go through this with the Northrop Grumman too. I mean, there's a lot of training that goes into, or in seminars, things like that the scientists have to go through to understand what they can and cannot disseminate to other governments and how to be careful. I mean, my time at LASP there, it was every 3 months you'd have to have a new class or something that went over things of what you can and cannot say or share with others. So there is that worry that's top of mind that the scientists are seen in that way.
Yeah, I know from my perspective, all the ITAR, DFARS training that we have to go through, special export, you know, inspections and making sure that we're not disseminating anything to even countries that we are allies with or partners with. Yeah, that's definitely something that I've had to experience on my end.
Thank you. All right. Okay. So our next question is, do you think that one day we will see military alliances around space, or is that already happening? And if so, does that put future space law treaties at risk for moving forward, especially when it comes to military operations in space?
We are already seeing military alliances around space, not in so many words, right? Again, international law applies to space when we're talking about relationships between sovereign states. Things that, we look at things like NATO, for example, using space assets together and relying on space assets to help each other and help those alliances. So, like I said, the Outer Space Treaty does not state that outer space shall be used exclusively for peaceful purposes. And we know that many countries have space forces, and many countries are anticipating a need for a military presence in space. You can have a military presence on other celestial bodies, and in space, the celestial bodies have to be used exclusively for peaceful purposes. But there's no rule that says you can't have a military base on orbit around the moon, or some such. So this is something that I think we will start to see more openly.
Yeah, and I think Michelle, like we talked about the other day with the Wolf Amendment, and I think it was 2011, where we have to have special. Well, we can't have any sort of really relationship with China in regards to space collaboration. So there's a alliance being made with Russia for lunar exploration versus Russia being part of Gateway, like they were with ISS. They kind of shifted and are gearing towards that relationship with China.
All right. Thank you. Let's go to our next question. What does the due regard principle mean under IHL?
So under the Outer Space Treaty, we don't have a definition of due regard. And this is, again, something that is subject an issue with all of public international law, right? We use these terms, global commons, due regard, and we have no legal definitions. It drives lawyers bananas. Due regard right now has only been litigated once in an arbitral tribunal. It was the UK versus Mauritius, talking about some islands. And the tribunal said it's not going to be a bright line rule. It's going to be a balancing test. And so you're going to look at the party of the first part. What did they do? And what other options do they have? And then you look at the party of the second part, and I'm using obvious legal stupid terms on purpose because this is what the test looks like. And this is why we need to have bright line rules, because we don't want to talk about the party of the first part, the party of the second part, and what happened and how it could have been avoided and who was more damaged and so forth and so on, because that's just a lot of chatter when we could just say, no, we need a safety zone. You do not come within 100 yards of my operation, and we don't have to worry about what due regard means.
Okay, thank you. And Michelle, this is another question, probably more for you, but are there any interesting space law, case law that you would suggest people to look into if they're interested in the laws for outer space?
So unfortunately, no. But if you go onto our website, if you go to the marketplace at the University of Mississippi, you can purchase all of space law. And you can read that. You can also go onto our website where we have the Center for Air and Space Law website. We have opened up our Journal of Space Law, which we've been publishing since the 1960s. And every issue is now available digitally for free. So you can go on there and sort of start looking around at the issues, at the table of contents, and think and see the things that we're thinking about with respect to space.
Thank you. Okay. The next question is about the potential of pollution of space with various items and activities. What type of concern do the three of you have for the collection of space junk and debris that could potentially fall back onto Earth or even potentially hit the International Space Station?
Yeah, I guess I'll start with this one. It's a great point, because it's something that has been, I think, on people's radar for a little while. And obviously even the International Space Station has to change its orbit here and there to avoid debris sometimes, but it is getting more crowded there. There are concerns. I know theoretical, the name's escaping me right now, but there's something syndrome that would essentially create a cascading failure of satellites that would essentially disintegrate, create basically these small ballistic missiles orbiting around at 17,000, 18,000 miles per hour. So Kessler syndrome, yes, I think someone's just chimed in on the chat there. But so it's definitely a concern, and there's more and more funding going into mapping out a lot of this debris and coming up with ideas of how to deal with it. There's some commercial entities that are doing positing the idea of everything from putting catching systems out in orbit that would attract some of these things, to even terrestrial based like laser systems that essentially vaporize some of this space debris. So it's not at a level where we're concerned that we won't be able to launch off of the Earth or something like that, but it is one of those things that, again, is in that mix of concerns that we need to keep in mind for the future as we have more and more countries and more companies sending material up there.
And something really cool that Northrop Grumman is doing, on the sustainability side, is the mission extension vehicle, where essentially, as opposed to launching a new rocket when they run out of fuel, Northrop will send up a satellite that essentially latches onto an old satellite and gives it fuel, and provides it longevity versus having these satellites that have a pretty stringent mission duration. So Northrop is looking at space sustainability and giving longevity to satellites that are already up there.
And I'll just add, and I saw somebody, and a later question was, can you explain Kessler syndrome in simple terms? And I think, Joe, you talked about the cascade effect. I just, the fact that debris or objects in space travel at 17,500 miles an hour means that if you have a collision, it can be really catastrophic. And so what we've seen is we have a lot of rocket bodies in space. We have a lot of intentional collisions with ASAT tests. We've had one unintentional collision, which created a debris field. And so the Kessler syndrome is suggesting that the more debris we have, the more it's going to hit each other and make smaller debris. And then the more that smaller debris is going to continue to hit. So that you cascade and cascade and cascade until you've blocked your entire orbit with debris. And one thing that you should Google is you can see debris the size of a grain of sand causes divots in like the windshield of shuttle, right? Or in the cupola. And the biggest issue is, whatever you think we are, it's, I think, what is the expression, the boiling a frog, right? We are not in a dire situation yet. But the more debris there is, the more we're going to have to shield our own spacecraft, making them heavier, making it more expensive to launch. And then ultimately, if we don't start cleaning up our orbit, we will be in that cascade. And so one of the gaps in international law is that there's no rule that says you have to clean up after yourself in space. And that's one of the things that we really want to see due regard being harnessed. But due regard is very, very scary. And surprisingly, no nation has ever said to another nation, hey, you violated due regard by blowing up a satellite and creating this debris field, right? Because who wants to be the person to throw that first stone? So this is a real issue, and hopefully the law will be able to help with it.
And Joe, I have a follow-up question to something that you had mentioned about interballistic missiles. Do we have any space law with a position on the use of interballistic missiles in space?
So there's no law that says you can't send a missile through space. You cannot place a nuclear weapon or a weapon of mass destruction in space. That's the only bright line law that we have.
Yeah, but what's interesting about that too is typically like an ICBM does go, you could technically, I mean, you're teetering on the edge of space when you send an ICBM up or hypersonics. So I think that there are almost loopholes that these countries and even us that we follow in regards to that law that Michelle's talking about.
No, that's a great point too. I think that's also an interesting thing, just in the larger discussion of intersection of legality and science. And there's not always perfect defining lines. I mean, from a scientific perspective, you could talk about the main layers of the atmosphere. And once you get to the exosphere, then that could be a defining line for space. But internationally recognized is what the Kármán line, I believe, is what, about 100.
There's no international decision. There's no international agreement about where space begins.
There you go. That's the thing, is that it depends on how you would define that. And I've heard of the Kármán line at 100 kilometers, but then there's you can also talk about low Earth orbit and how it still has plenty of molecules from the atmosphere, which is why the ISS also has to raise its orbit sometimes. So even that's a good example of how science and legalese aren't always going to match up. And even in this instance where we don't even have a recognized actual boundary.
And Michelle, I wanted to follow up with something that you had mentioned about how nuclear weapons or weapons of mass destruction can't be placed in space. So the question we have, was the use of a nuclear weapon to destroy the asteroid in the movie Armageddon a violation of the legal prohibition regarding nuclear weapons in space?
The Armageddon question. Yay. Yes, absolutely violation of the Outer Space Treaty. No question about it. But there's some good news, because we are, as an international community, there is a planetary defense council, which actually comes together every 2 years to think about how we're going to defend against an asteroid like that. And the idea would be that if everybody on Earth can agree that it makes sense to use that nuclear weapon, then we will be able to, circumvent the Outer Space Treaty with respect to that, or make a special case for it. So I don't remember that Armageddon actually had sort of an international council aspect to it, but we would need to do that.
And just to dovetail on that, that's I think that's a great point too, in terms of needing to catch up with the international agreements with that, because scientifically there's a lot of things that we've kind of proven that can be conceptually can do, but we're not sure if we can do it from a international cooperation standpoint. I think a perfect example is talking about planetary defense is the DART mission, the double asteroid redirection test that happened was a year or two ago, I think it was. And that was really our humanity's first test of a kind of planetary defense system. And there's obviously a lot of complications that go into it, but essentially we just smashed a washing machine size robot into an asteroid to see if we could redirect its orbit, as a proof of concept of if we are able to image or detect an asteroid that's coming towards us early enough, could we actually do something to redirect it? And it was very successful, and proved that that's the kind of thing engineering and science wise we can do. But I think a big takeaway in some of the papers that came out of that was, but would it actually work in a real situation where we had to get all these countries on board to do that sort of thing?
All right, so we still have a lot of questions left. Thomas, how do you want to proceed? Do you want me to keep going, or should we just follow up with emails?
Yeah, let's follow up. If you asked a question that has not yet been answered and you're interested in a follow-up, if you could, over the next couple of minutes, just please put your email into the chat or send it via a private message to hosts and panelists. You can do that by using that blue drop-down message in the chat box and just select host and panelist, and then only we will see it. And then please indicate which question was yours, and we will do our best to follow up after this. But I want to thank our entire panel. I want to thank Rebecca for steering this rocket, as it were. And this is my favorite webinar that we've done in a long, long time. And that includes some Star Wars related ones, which are near and dear to my heart. I learned a ton, and I want to thank all of you for sharing the wealth of knowledge, insight, analysis that you brought here today. I think